Hello and welcome to PicoBYTE. I'm James and this is your monthly bite-sized top tip to keep your PicoScope tame. In this month's episode, we're going to give you a run through of the trigger modes and trigger types in PicoScope 7. If you want a more detailed dive into the fundamentals and applications of triggers, jump into Roger Berry's trigger series in the card above. A simple oscilloscope trigger is a user-defined voltage threshold to tell the scope to start capturing a waveform. This is useful for displaying a waveform in a steady, predictable manner rather than the waveform popping up whenever the scope feels like it. The default PicoScope 7 trigger settings are perfect for capturing a simple repetitive waveform, such as the basic square wave. But if you want to capture something that's high speed, has some sort of variety, or even a glitch, you'll need to use our selection of trigger modes and trigger types to capture them successfully and reliably. Starting with our 6 trigger modes: none, auto, repeat, single, rapid, and equivalent time sampling, better known as ETS. The first mode, none, allows the scope to run free. Your PicoScope will ignore any trigger settings and will start a loop of capture, display, and repeat. This mode is particularly useful when you're not sure what your test signal looks like, allowing you to easily see it and dial in your trigger settings. Auto mode is the default workhorse of the PicoScope. It takes the best bits from none and repeat operations to form its own mode. As long as your trigger settings are set up correctly, auto mode will work exactly the same as the repeat mode. If the signal dips or disappears, instead of thinking, "Where's my signal gone?"
James, you okay?
No. The scope will go into a form of free run, automatically allowing you to see what the signal is actually doing. The next mode in our list is repeat, sometimes known as normal mode. When you have your trigger threshold set correctly and run your PicoScope, it will wait for the signal to pass the threshold and trigger a capture. In this mode, if your signal disappears or stops hitting the trigger threshold, your scope will hold on to the last available waveform until it sees a new trigger. If you want to capture a single waveform such as a startup condition or a single serial packet, you can use a single trigger mode. Once this mode has been selected and run has been pressed, the scope will look empty until the trigger threshold has been met. Your scope will stop, leaving you with a nice clean image of your signal. Nice. Rapid triggering is similar to single, but you can capture more than one waveform at much higher speed using your PicoScope memory and the waveform navigator. You can set the number of captured waveforms and run this trigger mode. The PC will then wait for your PicoScope hardware to capture the set number of waveforms and then stop. You can then navigate through the captures in the waveform navigator. The advantage of this is that if you have a high-speed signal, all of the post-processing will occur after the specified number of waveforms have been captured, so you won't miss a pulse. Lastly, we have equivalent time sampling, known as ETS. This is perfect for high-speed, repetitive signals, as the PicoScope will take multiple sweeps at different time offsets to build a detailed waveform. If there's any variance to the signal, like a serial communications bus or a frequency modulated signal, it won't look like the original signal. It will look more like this, which isn't very useful. Now you know your trigger modes, PicoScope 7 also offers a variety of trigger types. You can use these trigger types on different thresholds and characteristics of your waveform, opening up an opportunity for error detection and serial triggering. These types include simple edge, advanced edge, window, interval, pulse width, level dropout, runt, digital pattern, and logic. That's a lot. With all our previous examples, we've used single edge triggering as our trigger type, allowing you to set a threshold for the voltage to cross, either with a rising or falling edge, and add an amount of pre-trigger to see before and after the trigger. Remember, you can also change the trigger voltage and pre-trigger by moving the little yellow cursor around the screen. The next step up is our advanced edge trigger. This is the same as a simple edge, but opens up extra configurable options. It adds the ability to trigger off a rising, falling edge, and both at the same time. If you want to add a delay to the trigger further, then you can move the trigger off the screen, or if you want to add hysteresis to prevent noise triggering your scope, these are features that are also replicated in most of our other advanced trigger types. Following on from this is your window mode. This will allow you to trigger on waveforms that enter or leave a specified voltage range, helping you find over or under voltage conditions. This can be set with your 2 thresholds and selecting either entering or exiting as your direction. Interval and pulse width trigger types are similar in function. Interval will look for a full cycle of a specified time period where the start and end edge are the same direction, whereas pulse width will look for a single pulse of a certain duration. These are both useful when looking for a missing pulse of a certain length or triggering at the start of a serial packet. Level dropout looks for a voltage drop over a certain duration. If your power supply signal drops under the threshold for a set duration, the scope will trigger. If your dropout voltage is within a certain voltage window, you can also use level dropout window trigger. Then we have the Runt trigger. With this you can set a voltage threshold between 2 points to trigger on. If you set these between your voltage high and voltage low levels for a serial bus, the scope will only trigger if there is a pulse between those 2 levels, also known as a Runt pulse. Digital pattern is a trigger type specifically for digital signals on mixed signal oscilloscopes, also known as MSO. This allows you to set a trigger based on a specific pattern of high, low, rising or falling signals on a mix of digital signals. Lastly is your logic trigger, allowing you to use multiple channels through a logical function to trigger a capture. For each channel you can do a threshold level trigger or a window trigger. That's it for our PicoScope 7 trigger modes and trigger types. If you want more information or examples, be sure to visit our A to Z guide in the link below. Follow our socials, subscribe to our YouTube and ring that notification bell for all new videos and PicoBYTE episodes.